And in this module, we are going to go back to adding features to the gradebook and spending time with the C# language to understand some new syntax features and see how the language works. I specifically want to spend time with control flow in this module. So I want to look at the features of C# that let us branch, like the if statement that we've already seen, but there's also looping, jumping, switching, and returning. We'll see examples of all of these, as well as how to throw and catch exceptions to either create or manage those error conditions that occur in our software. Let's start by talking about branching in C#. The usual flow of execution in a C# application is to start with a line of code like line 10 here, and then just keep executing and moving to the next line of code until we get to the end of the program. But along the way, there might be statements like looping statements, the for each statement, that alter this flow, and we can also have branching statements where we branch to a different line of code depending on some condition. And we've already seen one branching statement in this course. Earlier in the course, we used the if statement. So with the if statement, I can check some condition and branch the flow of execution, so I go to one piece of code or a different piece of code. And let's imagine that inside of this add grade method, I wanted to make sure that the grade is actually greater than or equal to 0 or less than or equal to 100. I can express that logic inside of an if statement and only add a grade to the book if the grade matches those conditions. So first of all, if the grade is less than or equal to 100, that's one condition I want to use, and I could put grades.addGrade inside of the curly braces here, so we only execute this line of code if we branch inside of this block because that condition returns true. So if grade is less than or equal to 100, we'll branch in here, execute grades.addGrade. But I also want to check to make sure the grade is greater than or equal to 0. So if someone gives me a negative number, I don't want to add that to the grades. One way to express that logic is to nest one if statement inside of another if statement. What I generally prefer over a nested if statement, when possible, is to instead use some Boolean operators to combine those two logical checks into one expression. So I can say if grade is less than or equal to 100 and, with a double ampersand, grade is greater than or equal to 0. So this logic is the same as what we had, but now instead of two if statements, I have a single if statement. Some of the other Boolean operators that you will see include or. And this particular line wouldn't make any sense to say grade is less than or equal to 100 or grade is greater than or equal to 0, because what can happen if someone passes in a negative grade like -5? The way C# works, that if statement, we will check first, is the grade less than or equal to 100? That returns true. Therefore, the way the C# program executes is we'll say, yes, this statement is successful. Let's go and branch inside of the block and add the grade. Because in a C# program, if the left-hand side of an OR expression returns true, we never need to evaluate the right-hand side because we're saying if this is true or if the right-hand side is true, but we only need to check the right-hand side if the left-hand side is false. That's known as short-circuiting in some languages, and it's not true with the AND operator because now we have to make sure that both sides of this expression evaluate to true. The grade has to be less than or equal to 100 and the grade has to be greater than or equal to 0. So if we pass in a -5, sure, the left-hand side will return true, but we also have to check the condition on the right-hand side to make sure that both evaluate to true. And by the way, if you want to check to see if something is exactly equal, which is always dangerous with floating point numbers, as we discovered earlier in the course, I could say if grade equals, let's say, a 90.0. So double equal symbols, and that differentiates this equality operator to compare if two things are equal from an assignment operator, which is just a single equal sign. So down here, I am saying instantiate a new instance of the statistics class and assign that value into the result variable. Whereas up here with the double equals, I'm saying please compare grade against the value 90.0 to see if they are equal. And don't worry, if you forget to use a double equal sign, you'll typically create some sort of error. In this case, what the C# compiler is saying is you're assigning this value 90 to grade, and so you're basically saying if 90. And 90 is not a Boolean value. It's not a true, it's not a false. We're not going to know what to do with that at runtime. So you have to write an expression that produces a Boolean value, true or false. And to do that, I need Boolean logic operators like equals and greater than and less than and the AND operator and the OR operator and so forth. Now, something we'll come back and revisit later in this module is that we should really tell the user something if we're not going to add a grade to the gradebook. We should have some sort of message that lets them know something went wrong. For right now, I'm just going to add a write line that says invalid value, and later I will come back and show you a better way to do this. Now, if you want to take an optional challenge at this point, write a unit test that will prove that the logic inside of add grade is working correctly. In other words, inside of a new unit test that you create, instantiate a book and then try to add a grade of 105. There are a few different looping constructs that you can use with the C# language. One looping statement that we've used already is the for each loop. So this is saying for each grade that you find in the grades collection. And now the code that is inside of the block here will execute once for each grade that we find, and the value of each grade will be passed in as this grade variable. So that's one way to write the loop, but let me show you a few others. And what's interesting about this exercise is you can try this on your own and make sure that the unit tests are passing each time you change the style of the loop that we're using. And the unit test can prove that the program is still working correctly even though we've made some changes to the code. That's one of the beautiful things about having unit tests in place. But first, let's look at the do while loop. So with the do while loop, I used the do keyword. That comes above my opening curly brace. And after the closing curly brace, I express a condition, and that condition will tell the runtime should it continue to do this loop. So with all these other looping statements that we're going to use, we're no longer going to have the grade just handed to us by the looping statement. Instead, we're going to need to keep track of which index we're looking at in the series of grades, the list of grades that's available. And we're going to have to peek into that list to pull a grade out. So let me declare a variable. Let's call it index. Some people would just call it I, but I'll call it index. And index represents where we are in looping through the entire list of grades. So I always want the ability to say grade sub index to, let's say, give me the first grade on the first time through this loop. And I'll use that once more here to add up the average. And now I don't want to go to grades. What I want to do is go to grade. So I want to go to the list of grades. And here's where I want you to pause the video and jump in and see if you can complete this. So we need to do two things. First of all, we need to write a condition inside of the while statement here that will tell the runtime when to terminate this loop. So when have we examined all of the floating point numbers that are in that list of double? And the other thing we're going to need to do is maintain our index. So the first time through our loop, the index is 0, and we will be looking at the first grade. But the second time I come through this loop, I want to look at the second grade. So see if you can add those two pieces of information to the code and make the unit test pass, and then come right back. Here's how I'm going to solve the problem. Down here, before we check our while condition, I'm going to say add 1 to the index. So I can do that by using the plus equals operator, index plus equals 1. That will ensure that we're always bumping up the index by 1 and looking at the next grade the next time we come through this loop. And I can also do that by saying index plus plus. That's a fancy way of saying add 1 to the index with the plus plus operator. These days, I almost prefer to see plus equals 1 because it's very clear and evident what is happening there. And now I need to add a condition. I need to tell the runtime when to stop looping, and a good condition might be to say while the index is less than grades.count. And yes, I want to use less than. Because remember, if I have 4 grades in my gradebook, the count of grades will be 4, but the last item in that list will have an index of 3. So I want index less than grades.count. And this is a good place where you can have unit tests to make sure that you're not missing a grade, or that you're not off by 1, or that you haven't allowed the loop to try to index into the grades collection and reach something that doesn't exist inside of there. And now I just need to terminate my statement with a semicolon, and that's the do while loop. Now, one thing to be careful of with a do while loop is that the loop is always going to execute at least once. We're always going to come in and start executing this block of code at least once, because we do not check the condition for looping until we reach the end of that block of code. So we do this code while some condition is true. And that means if I have a list of grades that is empty, this code can fail because I'll be trying to index into the grades list with an index that doesn't exist, index 0. And that's where I would either need to surround this with an if check and only execute this loop if grades.count is greater than 0, or I can change this to a while loop. So with a while loop, I place the condition at the top of the loop instead of the bottom of the loop. And let me just cut out this expression down here, cut this out, and take it to the top and say while index is less than grades.count. So now, before we start this loop for the first time, we're first going to check this condition. And in the event that grades.count is 0, because there are no grades in the list of double, I will not execute any of the code inside of the loop. That's the primary difference between do while and while. Do while will always execute at least once. And now let's look at one more type of loop where I do not need to declare this index variable, at least I don't need to declare it on a separate line, because now what we're going to write is a for loop. Now with the for loop, I don't need the closing semicolon, I'm going to remove that. But I do need to write a statement that consists of a couple different pieces. Depending on your experience with different programming languages, this might look very strange or it might look very familiar. But when I write a for loop, I can first write an initialization expression. So the initialization expression gives me the opportunity to declare a variable or initialize a variable or declare and initialize a variable that I'm going to be using through the rest of the loop. So this is where I can now say var index equals 0. So I've declared a variable index. It's going to be of type int, and its initial value is going to be a 0. Then I use a semicolon, and I write the second piece of my for statement. The second piece is going to be the condition to check before the runtime enters the loop. So this is the condition I write to say I only want to execute the code inside of here if this index meets some criteria where it's actually going to be able to pull out a grade. So I can say if index is less than grades.count, that's going to be my condition. So we saw that condition before with the while loop, but you can think of this for statement as sort of a fancier while loop that concatenates a few things together inside of the for statement itself. So here's my variable declaration, here's the condition that I check, and then finally I can write a third expression here, which is the operation that I want to perform after each iteration of the loop. So after we finish the loop each time, what I want to do is add 1 to the index variable. And that means down here at line 39, I can remove this line because we're performing that operation up here. So what we have now is a for loop that will behave just like the for each loop that we had previously. It's just using a different syntax where we're being a little more explicit about how we're accessing each grade in the grade collection. So which of these looping statements should you use? I generally use the for each statement whenever I can. I think it's the clearest, most concise form of looping. I only use a for statement like this when I need some low-level control or I have some collection that just doesn't support the for each statement. We're going to talk a little bit later in the course about some of the magic that actually occurs behind the for each statement. And then occasionally I might use a do while loop when I have a loop that I am sure I want to execute the code inside at least once. But otherwise, the for each looping statement is typically what I want to use. Let's talk about the jumping statements in C#. Jumping statements allow me to jump over code to reach some other line of code that's in a method. And in general, you have to be very careful with jumping statements because sometimes it's hard to follow the logic of a method that uses jumping statements. But let me show you two common jumping statements. The first one is the break statement. So let's say I'm inside of this for loop and I decide that if I see some specific grade as I'm looking through the entire list of grades, if I see some specific grade value, I want to halt calculations at that point. So if I see grades sub I or sub index, if I see a specific value like 42.1, so I'm just making up a scenario and writing arbitrary code here, but if I see that value, what I want to do is skip over the next 3 lines of code, and not only skip over this code, but stop iterating through this loop. So even if my index plus 1 is still going to be less than grades.count, I want to stop the loop early. If that's the case, that's where I can use the break statement. You can think of break as the ability to break out of this loop. So we're going to not only skip these lines of code, we're going to break out of the loop entirely and end up here on line 45. Which would then not compute the correct average, by the way, or there's a possibility it's not going to compute the correct average because we have not added up all the grades, but we're still dividing by the count of all grades, so the average is going to be too low. But this is what the break statement will do. On the other hand, imagine we see this value 42.1, and it's just that one singular value that we do not want to include in the calculations. In other words, I want to skip these 3 lines of code, but I want to keep looping if the index is still inside of the count of grades. If that's the case, instead of a break statement, I can use a statement continue, which is a way of telling the runtime continue with this loop. So skip over these lines of code and just go ahead and continue with the next iteration you should check the condition and you should increment index by 1, but I'm ready to go the next time through the loop. The third jumping statement, which I almost hesitate to mention because in 20 years of C# development, I've only seen it used once, and that was not a business application, is the goTo statement. So with goTo, I can say goTo and then some arbitrary label that I pick, and a label would be an identifier that I apply to some line of code. So I could say here that I want the label done applied on line 45, or even to make things more interesting, here on line 47. And this is a way of saying, if we see the value 42.1, just go to done. Just jump to line 48 and return a result, even though we haven't calculated the average and we haven't made it the whole way through the loop. That's what goTo will do, but no one really uses goTo these days. So maybe you should pretend that you didn't even see that. Now I want to talk about the switch statement in C#. So back when I was growing up, we had the concept in my school of a letter grade. A letter grade would be a grade that you received as a letter instead of a number. So the letter grades were A, B, C, D, and F. A was the best grade, F was the worst grade and typically considered failing. So it might be that you failed a test or failed a homework assignment. And what would happen if I wanted to give users the ability to add a letter grade to the grade book? In that case, I might create a method, addLetterGrade, that instead of taking a floating point number, will take a single character. So not a string of characters, but there is a type in C# that allows you to take a single character. That's the char type, or what some people will call the char type, C-H-A-R. That's a single character. I will name this parameter letter. And if we use the F12 trick to see if character is a value type or a reference type, we will see that character is defined by a struct, so it is a value type. And now you might wonder why I added a new method here, or a method with a different name than addGrade. We'll come back and talk about that a little bit later in the course. There is another way to do this so that I can have addGrade that takes a double and addGrade that takes a letter, but I just want to defer that discussion for now. But what we have to do inside of this method is map from a character into a number, because ultimately we're storing numbers. So I can come up with an arbitrary list of saying, well, the letter grade A maps to the number 90, and the letter grade B maps to the number 80, so it would be a grade of 80. And I could express that logic using if statements. So I could say if letter equals an uppercase A, then what I want to do is invoke my addGrade method and pass along a 90. Otherwise, what do I want to do? Well, I want to point out that there is an else if statement in C#. It works just like the if else statement, except instead of automatically executing the else when the if condition up here fails, we first have to pass another condition before we execute the block of code defined by this else if. So I could say else if letter equals an uppercase B, then we add the grade 80. And I could continue doing this, but there's another way to express this logic, and that's using the switch statement in C#. Here's how the switch statement works. I use the keyword switch, and then I provide the variable that the switch statement is going to operate on. So I want to switch based on the value that is in the variable or the parameter named letter. And then I can provide different cases for the switch. This is where I can write code so that at runtime, my program will compare the letter value to the value of some constant that I express here. So the way I do this is with a case statement. So I'm essentially saying, in the case where the letter is equal to an uppercase A, then I use a colon, and I want to execute the following code. I do not need to use curly braces here to denote the block of code that I want to execute. I can just start writing code here, like addGrade, and I can have multiple lines of code. But this would add the number grade 90 when the letter grade is an A, and then I can have my next case, which would be if the letter grade is a B. And notice that I am using single quotes here to express a character. If I were to use double quotes instead of single quotes, then the C# compiler would treat my constant as a string. That's not what I want. I want a constant that is itself a character. And for this, I can say I want to add the grade 80. Now, before I continue, I want to point out that I do have a compiler error here. The error is that control cannot fall through from one case label to another. What the C# compiler is saying is that I need to see something else inside of this case statement that will explicitly control the flow, because in some other languages that also have switch statements, you could write a case that has some code, and then if you didn't explicitly control the flow of execution, the runtime would just keep going down to the next line of code and execute that line of code. So you could have situations where you pass in the letter grade A, and that would add the grade 90, and then also add the grade 80, because that's the next line of code. The C# compiler wants us to explicitly forbid that, and one way to do that, the most common way to do that, is to use a break statement. We saw the break statement earlier inside of a loop, and this break statement does the same thing. It's going to break out of the switch. So the next line of code that is executed after I add a grade of 90, when the letter grade is an A, would be the line of code that comes after the switch statement. And if there is none, then the method is finished executing. So let's add our break statement here. I can continue this exercise and say case when we have a C, and notice these are all constant values. So A, B, and C, these are all hard-coded values. They're not dynamic values being computed at runtime. In this case, I want to add the grade 70 and then break. I could also have a case for the letter D, but then what happens if letter does not match any of these cases? Well, that's something that is legal and can happen, and in that situation, I would not execute any of the code that is inside of here. But if I want to have a case that will execute when none of the other cases do execute, then I can use the keyword default and say, here's what to do by default. By default, what we're going to do is add a grade of 0. So that would happen currently if I receive a letter that is anything other than an uppercase A, B, or C. So if someone passes an uppercase F or a lowercase f or the letter Z, we will add the grade 0, and then we will break out of the switch statement. And this is an example of the simple switch statement that has been around in the C# language since the very beginning. Next, I want to introduce you to a slightly more sophisticated switch statement. Starting in C# version 7, the switch statement became a lot more powerful. In C# version 7, Microsoft gave the switch statement the ability to do what we call pattern matching. Now, typically, pattern matching is used to match some variable against a certain type. So if I want to find out if some object at runtime is really a book or a console or an employee or an invoice, that's typically the type of scenario that you use with pattern matching. But the features that they added to the switch statement also allow me to do some additional things. So here's what I want to do. Inside of get statistics, I not only want to compute the average grade, I also want to compute the letter grade for that average. So when I was in school, any grade that was 90 or greater would have a letter grade of A. An average grade of 80 or greater would be a B. 70 or greater was a C. 60 or greater was a D. And anything below 60 was an F or failing. And so what I want to do is come into statistics, and in addition to computing the average, the high, and the low, I want to create another field, a field of type char, and call it letter. We're going to compute the letter grade. And over in program.cs, in addition to writing out the average and the high grade and the low grade, I also want to write line the following string, which is the letter is, and then use the expression stats.letter. So we will be able to see the letter grade that is computed. So given the rules that I just gave you, what I want to do here after we compute result.average is do a switch on result.average. And I do want to point out this is only one way to achieve this in C#. There's various ways you could do this, including just writing if-else statements. And to some people, the if-else statements might be cleaner code, might be easier to read. But let's try this with the switch statement. What I want to do is say case, and now I'm going to use some of the enhanced powers of the switch statement, which allow me to declare a variable in my case statement. So I can say var d, and what will happen is I will now have a variable available inside of this case statement. The variable name will be d, and at runtime, the variable d will receive the value that is in result.average. So inside of this case statement, I effectively have a variable named d that will contain the average grade. And now I can use the next powerful capability that was added to the switch statement, which is the ability to use a when keyword. The when keyword allows me to provide a condition that will be evaluated at runtime, and only if that condition returns true will I execute the code that is associated with this case statement. So previously in our switch statement, we just had to use these constant values. Now I can take a variable and essentially say when d is greater than or equal to a 90.0. Now I still use the colon, and I can write a block of code that references the variable d. So in this case, I could say that the result.letter should equal, assigned to that, the character A. And once again, I will use a break statement. Now let me copy these few lines of code So I can say case D, and when D is greater than or equal to 80, let's use a B. I'm going to paste one more time. When we are greater than or equal to 70, that letter grade should be a C. When we are greater than or equal to 60, that's a letter grade of D, which is getting bad, but it's not quite as bad as getting an F, and we will just make that the default case. So the structure of the switch statement is the same. In fact, it is the same switch statement that we saw previously. There's just some additional features in C# version 7 that allow me to declare variables, allow me to use this when condition. And for advanced users, this switch statement does pattern matching, which effectively allows me to do some type matches, type comparisons. And we'll learn more about how that can be useful a little later in the course. What I would suggest you do before you even implement all this code, maybe you've been following along and you've already typed all this, is to go into your test and assert that you are computing the correct letter grade, at least for this one simple scenario that we have here. So what I would do is assert that given an average grade of 85.6, that should be a letter grade of B. So I would write an assert that result.letter is in fact the letter B. Let's save all that, come out to the command line, do a .NET test, and I'm hoping to see green text scroll by, which does happen. That test run was successful. I know I computed the correct grade. Now it's time for a challenge. What I want you to do is make changes to this program so that instead of hard coding these grades into the program, you're actually taking grades from the console and you're typing grades into the program at runtime. So when I run this program, I want the program to prompt me and say, please enter a grade. If I enter a number like 72, that number is added to the book. And I want you to set up a loop so that I can enter as many numbers as I want. Only if I enter the letter Q will you stop accepting grades and you'll go ahead and compute statistics and show those statistics on the console. So effectively, you need to have a loop right here that will continue asking me to enter a grade on the console, and you'll take that grade and enter it into the gradebook. I'm going to give you two tips, two things you need to know. First of all, if you want someone to type to enter something into this program, what you can use is a console.readline. So WriteLine puts something out into the console. ReadLine allows me to type with the keyboard and press the enter key to give you input. So if I type 7, 2 and enter, input will be a string with the characters 7 and 2 inside. In order to take that string and put it into a double precision floating point number, you're going to need to parse that string. The easiest way to do that is to use a static method that is available on the double type, and that static method is the parse method. So I can say, please parse this input so that if I enter 72.3, that will become the number 72.3, and I'll have that available in this grade variable, and then I can insert it into the book. So those two lines of code you should find helpful, but what you need to do is set up the loop so that you take input from the user. I'll show you my solution in the next clip. There's various ways that I could implement the code to fulfill the requirements that I just described. So what I'm going to show you is just one possible working approach. First of all, I know I need to loop until I reach some specific condition. I need to loop until the user enters a lowercase q. So I'm going to go ahead and declare a variable named done and set that equal to false. So this variable will be my flag. When do I finish looping? I finish looping and stop looping when done is true. So I'm going to write a while loop that says while I am not done. So the exclamation point in C# is the Boolean operator that flips this expression. So if done is true, not done is false. If done is false, not done is true. So while I am not done, please execute the following code. And what we will do is now take our input. So allow the user to enter a grade, but how does the user know they're entering a grade? Well, it might be nice to first do a console.WriteLine that says enter a grade or enter the character Q to quit. Now the user has some idea of what they need to do. The next thing I could do then is parse that input into a floating point number. So let me copy that code and paste it up here. I want to parse the input into a double, but what happens if the user just entered a Q? Well, I can tell you this parse is going to fail. There's no way to parse a Q into a double. This code will fail, so I really want to get out of here if the user did enter a letter Q. So we can use one of the jumping statements that we looked at earlier. I can say if input is equal to the character Q but that's not going to be quite right because here the C# compiler detects that input is actually of type string because console.readline returns a string. It returns a full collection of characters, and I'm trying to compare that to a single character, which is the lowercase q. The easiest thing to do here, there's again several ways to solve that problem, but the easiest thing to do is just to make q a string also. So I'm saying if input is equal to a string which is the letter q, well then we are complete. So I could set my done flag equal to true and then do a continue. And what that will do is skip over the parsing and jump right back up here to the top of the loop. See that the done flag is now true. So we would exit the loop and come down to book.getStatistics. And you might say, well, why instead of going to all that work, why don't you just say break and break out of this loop? And that's perfectly acceptable too. In fact, if I use the break statement, I don't have to have a done variable. I can get rid of that. And I can just write something that looks like an infinite loop. I can just say while true. So execute this loop forever, except we do have a break statement in here that will allow us to break out of here. So now we've handled that situation. We're parsing the input into a double. Now the only thing left is to walk up to the book and tell it to add this grade that we just parsed, and then to try it again. Let me save all the files, including program.cs. Let's come out to the command prompt. What I want to do is .NET run a specific project. So I went to .NET run and specify the project that is in the source folder. It is my gradebook project and it is gradebook.csproj. I hope I get a prompt to enter a grade or Q to quit. That's looking good. So let's enter the grade 95 and then let's enter the grade 85 and then let's try a 75 and then I'm going to try a Q to quit. And looking at the results, that the lowest grade is 75 and the highest grade is 95 and the average is 85. All those numbers seem very reasonable and seem correct. The letter grade of a B, that is correct for an average grade of 85. So it looks like the program is working. And hopefully you came up with something similar. But let's go one step further. What happens if the user enters a grade that is just a series of characters? So the cat walks across the keyboard and presses enter, and I have a fatal crash. I have an unhandled exception, a system.format exception. Earlier in the course, we saw a null reference exception. So this is a different type of exception, but the result is still the same. Our program has come to a crashing halt. And this is an error condition that we really should handle because we should expect a user to give us invalid input. In fact, believing that your user will always give you good input is what gets the software industry into a lot of trouble. That leads to a lot of the security vulnerabilities that we see in the world. So we should expect something like a format exception to happen. How do we deal with a situation to keep the program alive so it can continue running? Before I show you how to deal with exceptions so that the program can keep running even when the user gives me bad data, I first want to show you how you can produce an exception. So let's go back to the example inside of the book where we have the method addGrade, and we want to make sure that the grade being added is less than or equal to 100 and greater than or equal to 0. Currently, if that condition is true, we go ahead and add the grade. Otherwise, we do not add the grade, and all we do is write something to the console that says invalid value. Sometimes that's the right approach for software. We can expect that we will occasionally receive an invalid value for a grade, and perhaps we just want to provide a little bit of feedback, a little diagnostic message that says that value we just received, that was invalid. But other times we might want to create our own exception because that invalid value that we received should never happen. And we want to make it very clear to the caller that they have done something erroneous. They have tried to add a value that cannot exist in the gradebook due to the business rules, and we want to make sure they know about that. We don't just want to write out something to the console that the user will see. We want to create an error condition. And the way to create an error condition is to throw an exception. So there is a keyword in the C# language, which is throw. And the only types of objects that you can throw are exception objects. So I want to throw a brand new exception that I'm going to create. And you can see in the IntelliSense window here, there's actually a number of built-in exceptions in the .NET framework. So just like .NET provides classes to represent doubles and strings and consoles, .NET also provides some built-in classes that represent exceptions. Now, quite often in a larger system, you want to build your own custom exceptions, but that's more of an advanced topic. I'm going to show you how to work with some built-in exceptions. So anytime you receive a parameter value to a method, and you believe that parameter value is invalid, there's already a built-in exception that describes that scenario, and that is the argument exception. So if I throw a new argument exception, I'm saying there is something wrong with one of the arguments to this method. And typically what you do with an argument exception is use a constructor that allows me to pass along a description with some additional information. So I can add a string to this to say something like the grade is invalid, or perhaps invalid grade. This is very useful if there are multiple arguments to this method. So if I also took some sort of string parameter, then I want to let the caller know that the second parameter was okay, but it's the grade that was a problem. And so this is typically your parameter name. And instead of hard coding that here, there is a keyword in C#, which is the name of keyword. What I can do is pass in a symbol, which can be a method name, a field name, a parameter name, pretty much any identifier that exists in scope here. And what the name of operator will do is return the string representation of that symbol. So in this case, I will still have the string grade here, but now if I ever change the name of this parameter, I will be forced to change that name here also, so I can be sure that I'm producing the correct name. So now, if someone gives me an invalid grade, I will throw a new argument exception. And what does that look like currently? If I .NET run this project and enter a grade of 90, that works perfectly. If I enter a grade of 105, now instead of having a format exception crash my program, I have an argument exception crash my program. The reason this exception crashes my program is kind of implied by this keyword throw. What we're doing is throwing this exception, and someone else has to catch this exception if they want to handle this error condition. Otherwise, the exception is going to crash the program. And technically what happens behind the scenes when I throw a new argument exception is the runtime starts looking for a piece of code that can catch this particular exception. And it's first going to look in this method after I throw this exception. And if it doesn't find something that can catch that exception in this method, it's going to go to the code that called this method. So up inside of program.cs, when I say book.addGrade, I called that method. The runtime will look for something to catch that error here. It doesn't find anything. And when the runtime doesn't find any piece of code that will catch that exception, that's what can crash my software. So next, let's look at how we can catch or handle this error. If I expect a particular piece of code to throw an exception under some conditions, and I want to handle that error condition, that is, I want to catch that exception, I can use what's known as a try-catch statement in C#. Here's how a try-catch statement works. First of all, there's the keyword try, which is a pretty descriptive keyword because what I'm asking to do is to try the following lines of code. Both of these lines of code are inside of my try statement. That means I want to try to execute these, but I know that they might throw an exception, so I'm going to now use the catch keyword to try to catch and process those exceptions. And again, just to review how exceptions work, if I invoke double.parse and I pass in an input that is just gibberish, just a string where the cat walked across the keyboard, double.parse will throw a format exception. When double.parse throws a format exception, we skip over all the code that I'm trying here. So we skip over book.addGrade. What the runtime is looking for is the catch statement that is closest to where the exception was thrown. And currently, this would be the catch statement that is the closest to where the exception is thrown inside of double.parse. Inside of this catch statement, what I can do is essentially declare a variable. So I want to declare a variable. First of all, let me show you. I can declare a variable of type exception. Let's call that EX. And what this will allow me to do is catch any type of exception. So we haven't talked about inheritance yet in C#. We'll get to that later. But essentially, all the different types of exceptions that you can have, and you saw some in that list, like the argument exception, and you've seen the null reference exception, and you've seen the format exception. Those are all different types of exceptions, but they can all be caught by using a catch statement that says it wants to catch essentially every exception type. And inside of here, if I catch that exception, I can say, well, let's just console.writeLine the exception.message, and then continue on, because if I catch the exception, the runtime's not going to crash or terminate my software. We can just catch the exception and go back to the beginning of the loop and try again. Let's try this real quick. I'll save that file, come out to the command prompt. Let's do a .NET run. I will first enter a grade of 86, just to prove we can still get something into the book, and then I'll enter a grade of 106. That's an invalid grade, so you can see that message appear. And behind the scenes, we did throw an exception, but we also caught that exception so we can continue looping. And what happens when I enter gibberish? Well, now I display the exception message, which is input string was not in a correct format. But again, we continue looping, so I can enter another grade and I can press Q to quit. And now my program is not crashing. Sometimes crashing is really what you want to do, because if you catch an exception, well, something exceptional has happened. There's been some sort of error that has happened. And in some situations, that error might mean that your software cannot continue. Perhaps you were trying to write something into a database, or perhaps you're trying to write something into a file, and the file system is full, or the database doesn't exist, or the network is down. Every application is different, but there are some applications where you should just give up and say, sorry, I cannot continue. If that's the case, it's still possible to catch the exception to provide an error message to the user. But if I wanted to continue to propagate the error, what I can do inside of my catch is add a throw statement, and what this will do is rethrow the current exception. So if double.parse throws an exception, I'm going to catch that exception, and I'm going to write out the message, but then I'm going to rethrow the exception, so someone else either has to catch that exception or my program is going to terminate. Now I do want to point out that catching exception is not the right thing to do in all circumstances. Sometimes you want to catch a specific exception type, because if I use a catch block with exception, this will catch anything that goes wrong in double.parse or book.addGrade. And really, I don't know what errors might occur inside of double.parse and book.addGrade. I might run into memory errors if I try to add too many grades. I don't know. So in many cases, what you want to do is write a catch statement that will only catch the specific types of exceptions that you know you can deal with. For example, if I catch an argument exception, EX, well, I know addGrade can throw an argument exception if the grade is out of range, and I realize that's an error, but I can safely catch that error and then continue on. So I don't want to rethrow that particular exception. I just want to display a message to the user and then continue through the loop, enter another grade. So now I'm catching the argument exception, but what about the format exception that double.parse can throw if I enter in gibberish? Well, you can stack these catch statements. So I can say, I want to catch argument exception and execute this logic. And I want to catch a format exception. I will also name that EX. And I could here, if I wanted to, also write line ex.message to let the user know that they did not format their double correctly. So for many C# developers, this is the proper way to write a try-catch statement around these two particular lines of code, because these are the two errors I know about. These are the two errors I know I can handle and safely recover from, because I can just discard the value and allow the user to enter a new grade and we'll try again. And then one more keyword that you can use with a try-catch statement. You can also add what's known as a finally block. A finally block is useful if there's a piece of code that you always want to execute. You want to execute the code right here when the code inside of your try block executes successfully, but you also want to execute the code inside of the finally block when something here throws an exception. So let's say double.parse throws an exception. That will skip over addGrade, and if it's a format exception, we will jump to this block of code and execute this line of code, and then finally we will also execute whatever code is inside of this finally block, and I can have multiple lines of code. And this allows me to execute this console.write line regardless of the chaos that might be happening above me. And this finally block can be very useful if you're in a situation where you need to make sure that you close a file or close a network socket or properly clean things up even when there has been an exception. In this module, we saw if statements, we saw different types of looping statements, we saw the switch statement, and we saw how to throw and catch exceptions. And now it's time to turn our attention back to types in C#. What I want to do is show you how to add some additional members to a type like a class, as well as some new keywords that you can use to define types for .NET.